All right, these are the two things that we're going to start off with talking about in section 2.7. Okay, section 2.7 deals with inverse functions. Okay, this is one that you've seen forever and 3 years plus that. Okay, that just means it's the function. What does this one mean? Inverse. So if I say f of x equals 2x plus 5, find f negative 1 of x, or find the inverse of x, how do I do that? Switch x and y and solve for y, right? We know this represents y. It's not the same thing as y. You know that, but it's similar. And in this case, it's representing y, right? So if I switch x and y, I get x equals 2y plus 5. How do I solve for y? Minus 5. X minus 5 equals 2y. Divide by 2 on both sides. Now, what they told me last period was this is how the computer wants the answer. You can just leave it as x minus 5 over 2, but apparently the computer wants you to actually divide each term by the 2. Is that what it's doing?
I don't know, but I typed that in and it told me it was wrong.
Okay. I want you to separate it. Okay? Yeah. But you know that's the same thing. It just wants you to separate it. You know it gets kind of moody sometimes. Okay, good. I'm glad it helped. Okay? What about f of x equals the square root of 3x plus 6? Find f negative 1 of x, or find the inverse of x. How do we go about that? How do you undo a square root? So x equals the square root of 3y plus 6. So by squaring both sides, I get x squared equals 3y plus 6. Except I didn't write the squared. I said it. I think I said it. We'll pretend I said it. I can actually go back on the video and see, but who cares right now? Subtract 6 from both sides. X squared minus 6 equals 3y. So when I divide everything by 3, I should get 1/3 x squared minus 2. You okay with that? Maybe that'll help. Okay? Now, keep in mind, remember how we talked about compositions of functions last time? F of g of x and g of f of x, or f of g of x and g of f of x. Remember that? What happens when you do f of g of x and get x, and then you do g of f of x and get x? What does that mean? That means these two functions, f and g, are inverses. Okay? So they may try to trick you, though. I don't want you to be tricked. Okay? What if you do f of g of x and get 3x, and g of f of x and get 3x? Are they inverses?
No.
Why not?
Because they're not x.
They're not x. They have to equal x. What line do the inverse functions reflect over? Y equals x. Does it make sense that it would reflect over y equals x if their inverses, if their composition of functions both equal x? I hope so. Okay? Composition of functions equals x. Hopefully it makes sense to you that the two equations would reflect across the line y equals x. Yes, ma'am? F of g of x? Kind of. Yes, in this case, yes. Yes. Yeah. Yeah. Okay. Let's see. Here's a good one. What if they say f of x equals 2x plus 5 and g of x equals 3x minus 1? Find f of g of 2. Do you have to do f of g of x and get an answer and then plug 2 in? Or can you start right here with g of 2? Yeah, plug 2 in for x in g, right? So 3 times 2 is 6 minus 1 is 5. So g of 2 is 5. So that is 5. So now what do you have to do? Yeah, f of 5. Find f of 5. So 2 times 5 is 10 plus 5 is 15. So f of g of 2 equals 15. Does that make sense? Can you do g of f of 1? Where would I start?
Put the 1 in, F back.
Okay, so 2 times 1.
1.
Okay, let's try again. 2 times 1 is 2. 2 plus 5 is 7. So f of 1 is 7. So come over here. 3 times 7. 21 minus 1. So g of f of 1 is 20. Does that make sense? Okay. There's some table questions that can be tricky if you let them. Let's not let them. I need to know f of g of 4. Where do we start? What is g of 4? If x is 4, g is negative 2. So this is negative 2. What is f of negative 2? 3. Because it doesn't give you any equations on this. It just gives you tables. Okay? So answer this question. Could we find g of f of negative 1? Uh-oh. We don't know for sure. We don't know for sure, right? So is that not what we can do? Can we find negative 2 instead of negative 1? So f of negative 2 is 3. What is g of 3? Negative 1. Okay? Don't assume on this. Just use what you're given in the tables. I know that you saw the pattern. I'm very proud of you for seeing the pattern. Okay? So just be careful of that about that. If it was g of 4 is negative 2. I just didn't draw very straight lines. There you go. Go over here for negative 2 and find out that it's 3. Yes. Yeah. You good with that? Okay. Now on to something completely different, but not exactly different. Kind of the same-ish, but different-ish. I need to know if this function is, I need to know if this relation is a function. How would you go about knowing if this relation right here is truly a function? You can do the vertical line test. It is a function, right? Yes, it is a function. How do I know if the inverse is a function? Yeah. Horizontal line test. Is the inverse is not a function? Not a function. You should not feel dumb. What about this? Function. Inverse is also a function. Parabolas? No? Okay. Okay. You okay with that? Here's the deal. On functions like this, where the function is the inverse, where this vertical line test proves this is a function, and where the horizontal line test proves that the inverse is the function, this has a special name. It's 1-to-1. Okay? So if it tells you that something is 1-to-1, it's telling you that it is a function and its inverse is a function. You okay with that? Okay. That's section 2.7. You ready for section 2.8? I don't know if you are. Excellent. 2.8. You should have seen this before. So I'm glad you feel like you have seen it before. What is it? It's the distance formula. It is not another distance formula. It is another formula. Yes, it is. Midpoint formula. Can you guys manipulate points that you're given and to find the distance between the two and the midpoint between the two, or do I need to show you examples for that? I mean, this is back from geometry, right? Are you good with that? Okay, I will tell you this. You're telling me right now you don't need examples. I'm okay with that. But I will tell you that if you press that help question button and it takes you to the, click on the textbook, there's some really good examples in the textbook in case you get lost or something like that. Okay? No. Okay? In this section, though, when you're doing both of these, not necessarily the midpoint, but definitely the distance formula, I will go over this, because this is something you're going to need to remember how to do. Okay? The square root of 12, it's not going to take the square root of the 12 as the answer. I don't know why I said the square root of the 12. Okay? It's not going to take square root of 12 as the answer. It wants you to rationalize this. Okay? Which means you think in your head, I know that 12 is 4 times 3. Why did I choose 4 times 3 and not 2 times 6? Because you know that 4 is the square, right? So you know that that's the square root of 4 times the square root of 3. And you know the square root of 4 is 2 square roots of 3. You remember that? Okay. So I think most of the time it's assuming the positive here. So we don't, when we take the square root of 4, we don't have to put plus or minus 2. Okay. Because we're talking about distance, so we are using the positive. All right. So do I need to do any more of these, the rationalizing? All right, what about square root of 20? Four and 5, so 2 root 5. Did I skip too many steps? I'm trying to help you think of it out loud. Okay, what about square root of 200? 102, right? So what's the square root of 100? 10 root 2. Yeah, you want to choose the largest square root that you can, because that's going to help. Otherwise, you'll have lots of other steps you have to go through. Okay. Yeah, the biggest squared number that you can is what you want to think of. Okay. Let me see if I can think of an example. What about like if we were doing 72? Well, you know that one is divisible by 4, right? So if I did 4, what would that give me?
16, 18.
Okay, if I divide 4 into 7, I get 1, and there's 3 left over, so that would leave me an 8. Okay? Except, I know that inside 18 there's a 9, right? So then that would leave me as 4 times 9 times 2. Well, this is giving me all sorts of different steps, and if I would have just thought 72 is really 36 times 2, that would have told me right away it was 6 root 2. Otherwise, I have to do 2 and 3, which is 6, and get root 2. Okay? You still get to the right answer. I'm not telling you you're going to get it wrong. I'm telling you just have more steps. You can still absolutely get to the right answer. Yes. Yeah, it's easier if you find the biggest one to begin with. Okay? Okay, another formula you've got to know in this section is this one. Yes, I even taught you this before. That's how I know you've seen it before. Okay? That's okay. Does anybody remember what you got? Equation of a circle. Okay? We should be congratulating those people and not calling them a nerd. Because I promise you this, one day they'll be your boss. Okay? Where's the center of this circle? The center is at HK. What is the radius of this circle? It's just R. Okay? Good try. Good try. The radius is just R. Okay? Here's the other thing you need to know. X squared plus y squared plus dx plus EY plus F equals 0. We looked at this last year, but here's something different. Okay? When we wrote this last year, it was x squared plus y squared plus cx plus dy plus e equals 0. It's just different letters. It means the same thing. Everything that we did last year is what we're doing this year, just represented with different letters this time. Okay? I'll give you a hint. It's the equation of a circle. Yes, that's right. Okay, it's the equation of a circle. This one is just in the form where you can see the center really easily. This is the standard form. Okay, so what you have to be able to do, which is what we did last year in class together, you have to be able to, if given the equation of a circle in standard form like this, put it in this form by completing the square. I will remind you how to do that because we did spend quite a bit of time on it last year. But it's just reminding you. You've seen it before. Okay? First thing I'm going to do is get rid of this 23. I'm not just making it poof go away. I'm scooting it to the other side of the equal sign. Okay? The other thing I'm going to do at the same time is I'm going to gather my like terms together. Okay, so does everybody see what I did? I scooted these two terms together. I scooted these two terms together. And I moved this one to the other side of the equal sign. You okay with that? I did it all in one step. I'm trying to get you guys to get rid of unnecessary steps. You okay? Okay. Now, I just look at the x's. And I have to complete the square on the x's. Here's the pattern of completing the square like I taught you last time. Take this x term, divide it by 2, and square it. What's 4 divided by 2? What's 2 squared? If I add a 4 here, where else do I have to add a 4? Now take the y's. Divide this by 2. 3, square it. 9. If I add a 9 here, I have to add a 9 here. Because now what I've created is 2, 1 here, and 1 here. I've created 2 perfect squared trinomials. And once I have the trinomial, I go to the binomial. Exactly. How do I get the binomial from the trinomial? That's exactly what I'm doing. I'm factoring it. Okay? But perfect square trinomials, remember, have an easy way to factor it. I got the x. I can either half this term or square root this term. Won't it be the same thing?
2.
It's 2. And I need to make sure to take the sign of that middle term. Okay, that's important. I take the sign of the middle term. Okay? I need to go to the binomial. Y minus 3. You can either half this or square root this. Yeah, to get that number. It's okay. I still remember. Equals 36. So what it's going to ask you at this point is where is the center and what is the radius? Where's the center? -2, 3. Remember HK. HK, remember the negative sign is built into the formula. So -2, +3 is the center. And the radius, 6. Okay? One of the things that you're going to have to do with the distance formula and with the midpoint formula, excuse me, not so much with the midpoint formula, but with the distance formula for sure, it's going to tell you the center of a circle and a point that the circle passes through. Can you find the equation set up in this format if you know the center and a point that the circle passes through? Well, you plug this in for h and k, right? You could use that, or you could use a distance formula to figure out what the distance is from the center to that point, because wouldn't that be the radius? Yeah. Okay. I don't know. Your choice probably. You should, yes. Okay. Any questions? All right. Like I said, in the that book example are some examples of distance and midpoint formula if you need to see some of those. But other than that, that's 2.7 and 2.8.